Tonight, we're going to look at the longest journey it is possible to draw on a single map, a straight line from one edge of our galaxy to the other. That line is about 100,000 light years long. Light itself, the fastest thing that exists, needs 100,000 years to finish it. The span of everything humans have ever written down, every ledger, every letter, every name carved into stone, fits inside 5% of one crossing. And if you boarded the fastest machine our species has ever built tonight while the house around you goes quiet, you would die having crossed less than a millionth of the way. The distance does not merely defeat the traveler. It defeats the traveler's children and their children and every generation whose names anyone will ever remember. A crossing is not a voyage in any sense our species has practiced. It is closer to geology. It is a stretch of space so wide that stars are born, burn through their lives, and go dark in the time it takes to walk it. And yet the line is real. It has two ends. It sits on a map we have actually drawn, of a galaxy we have actually measured from inside, which raises the question this episode is built on. Is there any honest way across for anyone or anything ever? By the end of tonight, you're going to understand exactly how long the crossing takes for every vehicle we have ever built, what has already completed the journey while we watched, and the one strange loophole that physics leaves open. A loophole that would let a single human lifetime span the entire galaxy at a price no one has ever agreed to pay. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. The journey needs a starting point, and ours is almost embarrassingly local. Earth sits inside the disk of the Milky Way, roughly 26,000 light years from the center. Not at the heart of things, and not at the rim, but in the quiet middle distance, the galactic equivalent of a small town far from the capital. From here, the line runs inward, through the crowded interior, past the center, and out the far side, until the stars thin away into darkness. 100,000 light years, end to end. Every number in tonight's journey hangs from that one measurement. So before we board anything, we should be honest about what a light year actually is. It sounds like a unit of time. It is not. It is a unit of distance with time folded inside it. And that folding is exactly where this story gets strange. The light year is the distance light travels in 1 year. That definition is short enough to miss the point, so tonight we will take it apart slowly. Light moves at about 186,000 miles per second, not per hour, per second. In the time it takes you to say the word second, a pulse of light could circle the entire Earth more than 7 times. The moon, which took the Apollo crews 3 days to reach, is a little more than 1 light second away. The sun sits at 8 light minutes. When you stand in the morning and feel warmth on your face, you are feeling the sun as it was while your coffee was still brewing. 8 minutes of history, delivered to your skin. Stretch the ruler further. 1 light hour reaches out past Jupiter. 1 light day swallows the whole planetary system, the sun and every world you memorize in school, with room to spare. And 1 light year, the full unit, the distance light covers in 365 days of unbroken travel, comes to about 5.9 trillion miles. That is 9.5 trillion kilometers. The number is too large to picture, and that is acceptable. Nobody pictures it. Astronomers do not picture it either. They stop picturing somewhere past the orbit of Neptune, like everyone else, and let the mathematics carry what imagination cannot. Here is what matters for tonight. The nearest star beyond the Sun, Proxima Centauri, is 4.24 light years away. That is the width of a single gap between neighbors in one quiet suburb in one arm of the galaxy. The line we intend to cross is 100,000 of those units laid end to end, not the gap between houses, the whole continent of stars. A ruler made of speed has one more property worth noticing. It runs in both directions. Every distance it measures is also a delay. To look across 4 light years is to look 4 years into the past. Hold that thought. It will return near the end of the night, when the ruler folds back on itself in a way that very few travelers would welcome. The map deserves a moment of respect, because drawing it was one of the quietest triumphs in the history of measurement. We live inside the thing we are trying to measure. Nobody has ever seen the Milky Way from outside. Every photograph you have ever admired of a grand spiral galaxy, the glowing arms, the bright core, the elegant sweep, is a portrait of some other galaxy, standing in for ours the way a cousin stands in at a wedding. Our own galaxy we know the way you know your childhood house in the dark, by moving through it, by touch, by the accumulated evidence of years. The evidence says this: the Milky Way is a barred spiral galaxy, a flattened disk of stars shaped less like a ball and more like a vinyl record with a swelling at the middle. The bright disk spans roughly 100,000 light years. Some surveys of faint, far-flung stars suggest the disk's thin outer reaches may extend considerably farther, perhaps nearly twice as far, but the bright, star-crowded disk, the part any traveler would recognize as the galaxy, is the 100,000 light-year span we are crossing tonight. Within that disk lies somewhere between 100 billion and 400 billion stars. The honest answer is that no one knows the count more precisely than that, because most stars are small, dim, red things that hide from our surveys the way dust hides under furniture. 100 billion is the cautious floor. It is also, for tonight's purposes, already beyond comprehension, so the uncertainty costs us nothing. Our own address, verified by decades of parallax measurements and by tracking stars that orbit the galactic center. The Orion arm, a minor spur between two grander spiral arms, 26,000 light years from the middle. From a dark field on a clear night, you can see our situation directly. That pale band across the sky, the feature that gave the galaxy its name, is the disk itself, seen edge on from inside, billions of stars compressed by distance into a fog of light. You are not looking at the Milky Way. You are looking down the length of it. You live in that band. The line is drawn then. From one edge through the interior, 26,000 light years inward to our position, another 26,000 to the center, and onward out the far side. But before the first step, the map deserves one more service, a scale model honest enough to feel. Numbers with 17 zeros slide off the mind. So let us shrink the problem until one piece of it fits in your hand, and then watch the rest of it refuse to follow. Shrink the sun to a marble, 1 centimeter across, small enough to lose in a pocket, a reduction of more than 100 billion to 1. On this scale, the Earth is a grain of dust about 1 meter away. The entire orbit of our planet, the full sweep of every season, a circle you could draw on a living room floor. Neptune's orbit fits inside a modest yard. The whole planetary system, every world and moon and comet the sun holds close, is a patch of ground a stone's throw across, with a marble glowing at the middle. This is the neighborhood as most imaginations hold it, and at marble scale it is genuinely cozy. Now place the next marble. Proxima Centauri, the nearest star that is not the sun, lands at this same scale with our sun resting on your table, about 290 kilometers away. The distance from one city to the next city entirely. Between the two marbles, nothing. Not a thinner neighborhood, not scattered pebbles, essentially perfect emptiness. A marble in one town and a marble in another, and the whole highway between them dark. That is one gap, the standard gap between neighboring stars in our quiet suburb of the disk. And the galaxy is 100 billion marbles or more, sewn at roughly that spacing, in a disk that, still at marble scale, still with the sun 1 centimeter wide, stretches nearly 7 million kilometers from rim to rim. 7 million kilometers of model, about 18 times the real distance from the real Earth to the real moon. The scale model of the Milky Way, built with a marble sun, does not fit between here and the moon. It does not fit between here and Mars at its closest. Shrinking the sun by a factor of 100 billion produces a map that still cannot be laid out inside the inner solar system. That is the object we intend to cross. When a thing's scale model exceeds the distance to other planets, the word map is doing unusual work. Hold the marble. Keep the 7 million kilometers somewhere behind your eyes. Now we start walking. We begin with the oldest vehicle our species owns, because the arithmetic deserves to start at human scale. We begin on foot. A steady walking pace is about 3 miles per hour. A committed walker covers perhaps 25 miles in a day. Our species has crossed continents this way. Given ice ages and desperation, it crossed most of a planet this way. Walking is not a joke. It is the transportation that built the human world. Point yourself along the line then and walk. Do not stop for weather or night or oceans or the small matter of leaving the earth. Walk at 3 unbroken miles per hour, hour after hour, and the crossing of the Milky Way will take you about 22 trillion years. 22 trillion. The universe itself is currently 13.8 billion years old. You would need to walk through the entire history of the universe, every star that has ever formed, every galaxy that has ever turned, about 1,500 times over, back to back, before you arrived at the far edge. Somewhere in the first stretch of that walk, the sun would swell and die behind you. You would not have finished 1% of 1% of the journey. You would barely have left the neighborhood. And here's the thing worth saying plainly. This early in the night, nobody plans a walk like this, and that is not the point. The number is the point. 22 trillion years is not a travel time. It is a measurement of what kind of distance we are dealing with. a distance that treats the entire age of the universe as loose change. Every vehicle we board from here forward should be judged against that baseline. Each one will carve the number down, and each time, watch how much remains. Picture the walk itself briefly, because the texture matters as much as the total. The marble model told us what lies between the star households: nothing. A walker who somehow strode the actual line would leave the sun's warmth behind in the first fraction of the first year, and then walk in perfect darkness and perfect cold for the better part of 1 billion years before passing anywhere near another star. Then darkness again for another era. The journey would not feel like travel. It would feel like the absence of travel. No landmark, no milestone, no sunrise, one footstep after another through a corridor with no walls, while entire geological ages of home time expired between waypoints. The galaxy seen from within, at walking pace, is not a city of stars. It is an ocean with a port every 1 billion years. The galaxy does not care how the crossing is attempted, but the arithmetic, at least, is willing to negotiate. So we trade our feet for wings. The fastest ordinary machine most people will ever ride is a commercial airliner, cruising a little above 500 miles per hour. It is a beautiful, casual miracle. It crosses the Atlantic between dinner and breakfast. It shrank the Earth to a weekend. Aim it along our line and let it fly. No fuel stops, no descent, 500 and some miles per hour forever. The jet completes the crossing of the Milky Way in about 120 billion years. The walk took 22 trillion. The jet takes 120 billion. We have improved matters by a factor of nearly 200, and the travel time still comes to almost 9 times the age of the universe. Every commercial flight in aviation history, laid end to end, every route, every airline, every crowded holiday itinerary since the first airfields opened, sums to a thread of travel that would not register as a visible mark on the map of this one line. There is a particular feeling that arithmetic like this produces, and it is worth naming, because it will deepen as the night goes on. The numbers stop feeling like travel times and start feeling like categories. A walk and a flight are not two options for crossing the galaxy. They are two ways of saying the same thing: that human motion, the kind with wind and engines in it, simply does not participate in distances like this. The galaxy is not far away in the way that Australia is far away. It is far away in the way that the past is far away. More speed will help. It will not help the way you hope. It helps to remember what 120 billion years would actually contain, because the jet's number is the first one small enough to itemize. The sun has perhaps 5 billion good years remaining. Our jet completes the first 24th of its flight as the star that launched it swells, reddens, and dies. The Milky Way and Andromeda are due to merge on roughly the same schedule. The jet, faithfully airborne, would outlast the very galaxy it was crossing, arriving at coordinates that stopped describing anything 11/12ths of a journey ago. Even the stars themselves, as a population, are not provisioned for such patience. Long before the itinerary closed, star formation across the merged galaxy would be dwindling. The bright blue suns long gone, the sky reddening toward embers. A 120 billion year flight does not cross the galaxy so much as outlive it. Still, we have barely tried. The jet never leaves the air it swims in. The next vehicles throw the air away entirely. Chemical rocketry is the loudest thing our species does on purpose, and it comes with a firm ceiling that most people never hear stated. To leave Earth entirely, not to orbit it, but to leave permanently, a spacecraft must reach escape velocity, about 25,000 miles per hour, 11 kilometers every second. The Apollo crews rode that arithmetic to the moon in 3 days. It remains the fastest any human beings have ever personally traveled, and it was achieved by burning kerosene-scented tonnage at a rate that emptied a skyscraper-sized vehicle in minutes. Grant that speed to our crossing, sustained forever, and the Milky Way takes about 2.7 billion years to traverse. Notice what just happened. We multiplied the jet speed by nearly 50, and the answer is still measured in billions of years. When the first primitive cells were assembling themselves in Earth's oceans, a rocket departing at escape velocity would have needed to already be underway, and it would be arriving at the far edge of the galaxy roughly now, greeted by no one who remembered why it was sent, because the species that sent it had not existed when it left, and might not exist when it arrived. The problem is not engineering timidity. The problem is that chemistry has a ceiling. A chemical rocket is powered by the energy stored in molecular bonds, and molecular bonds hold only so much. You can build the tanks larger, and the equations answer by demanding more fuel to push the fuel, in a spiral of diminishing returns so steep that engineers speak of it the way sailors speak of weather. The tyranny of the thing. Fire took us to the moon. Fire will never take anyone across the galaxy. That is not pessimism. It is a property of molecules. So we set aside the vehicles we have merely imagined at their best, and we consult the two machines that have actually gone farthest and fastest. They are real. They are flying right now, tonight, while you listen. And their report from the frontier is the most sobering arithmetic of the night so far. Of everything humanity has ever built, one machine has traveled farthest from home, and it is still going. Voyager 1 left Earth on September 5th, 1977, took gravitational slingshots past Jupiter and Saturn, and has been climbing away from the Sun ever since, 49 years of unbroken departure. In August 2012, it crossed the heliopause, the boundary where the Sun's wind gives way to the thin breath between stars, and became the first human object in interstellar space. Its speed, out there in the dark, is about 38,000 miles per hour, 17 kilometers every second, roughly 3.6 astronomical units per year. Its distance tonight is about 23.5 light hours from home. Read that again gently. Hours. After 49 years of flawless, historic, record-setting flight, the farthest machine our species has ever sent is not yet one light day from Earth. This November, on the 18th of November 2026, by NASA's own calculation, Voyager 1 will finally complete its first full light day of separation. 1 day of light, bought with half a century of travel. The galaxy's crossing line, remember, runs 100,000 light years. Not light days. Light years, each one containing 365 of the units Voyager has spent 50 years earning one of. The machine itself, meanwhile, is running out of voice. Voyager 1 speaks to Earth through a radio transmitter no more powerful than a refrigerator bulb, heard across 23 light hours only because giant dish antennas on 3 continents take turns listening for it. Each reply now takes nearly 2 days, question to answer. Its plutonium heart loses a few watts every year. One by one, over the decades, its instruments have been switched off to ration the warmth, and sometime in the coming years, the last of them will fall silent. The spacecraft will not stop. It will simply stop calling home, coasting on, intact and mute, at 17 kilometers per second for millions upon millions of years. The silence changes nothing about the journey. It only ends the conversation. Hold Voyager's pace steady across the full line, and the crossing takes about 1.76 billion years. That is roughly 13% of the age of the universe. It is longer than complex life has existed on Earth. When the journey began, the most sophisticated organisms on this planet would have been sheets of algae. By the time it ended, whatever waited at the far edge would be separated from algae by more evolutionary distance than separates algae from us. And Voyager 1 is our best. Not a concept, not a proposal, our actual launched fastest outbound machine. One more spacecraft has a claim to the title, and its story sharpens the lesson because it was born faster and is losing anyway. On the day it left Earth in January 2006, the New Horizons probe was the fastest launch in history, thrown toward Pluto at just over 16 kilometers per second, quicker off the pad than anything before or since. Voyager 1 left its own pad 3 decades earlier at a slower pace. Yet tonight it is Voyager that leads the field, and New Horizons that trails behind at 13.5 kilometers per second, slowing as it climbs, destined never to catch up. The difference was the road, not the engine. Voyager happened to fly during a rare alignment of the outer planets, and it banked 2 enormous gravitational assists, at Jupiter and at Saturn, that New Horizons' single Jupiter flyby could not match. The fastest launch and the fastest escape are different titles, and the galaxy hands out neither with any generosity. But there is one machine that has moved faster than either of them, faster than anything human hands have ever assembled. The Parker Solar Probe, built to touch the outer atmosphere of the Sun, swung through its closest approach on December 24, 2024, passing about 3.8 million miles above the solar surface. At that moment, it was moving at 430,000 miles per hour, 192 kilometers every second. At Parker's record pace, New York to Tokyo takes under a minute. Earth to the moon takes about half an hour. Here is the honesty the record requires. Parker was not cruising outward at that speed. It was falling, diving deep into the sun's gravity in a bound orbit, converting the fall into velocity the way a stone converts a cliff, and it spent that speed climbing back out again. Parker will never leave the solar system. Its record is a borrowed number, achieved at the bottom of a gravitational well, in the one place a spacecraft can be handed such speed for free. But tonight, generously, let us grant the impossible. Take Parker's record, the single fastest moment in the history of human machinery, and hold it steady forever, aimed along our line. The crossing of the Milky Way now takes about 156 million years. Feel the shape of that improvement. We began on foot at 22 trillion years, the finest speed our species has ever achieved, granted permanently and impossibly, brings the answer down to a span in which the dinosaurs rose, ruled every continent, and were erased. The last time 156 million years elapsed on Earth, the Atlantic Ocean was a narrow strait. That is our best number so far. That is what a century of rocketry buys against this line. The vehicles are not failing. The vehicles are magnificent. The line is simply longer than the category of machine we know how to build. And before we meet the travelers that do complete it, we should pause and ask the quiet bookkeeping question underneath all of this. What would the crossing actually cost? There is a version of this problem that has nothing to do with patience and everything to do with fuel. It is worth opening that ledger once because the entry at the bottom is one of the most sobering numbers in physics. Suppose we skip past chemistry entirely. Suppose we command the most perfect engine that physical law permits, a matter-antimatter drive that converts fuel directly into light and throws the beam backward, wasting nothing. No such machine exists or is close to existing. Antimatter is currently manufactured atoms at a time, at a cost that makes gold look like gravel. But suppose, even for this flawless engine, the arithmetic of sustained acceleration is merciless. Physicists who work through the mass ratios find that a comfortable, continuously accelerating flight to a nearby star already demands tens of kilograms of fuel for every kilogram of ship. Stretch the trip toward the galaxy's interior, the kind of range our 100,000 light-year line requires. And the requirement climbs toward tons of perfect fuel for every single kilogram of payload delivered. Tons of the most expensive substance in existence per kilogram of person. A crew member with luggage prices out at a mountain of annihilating fuel. The perfect engine does not fail because of engineering. It fails because of bookkeeping. Because the universe charges for speed in advance at rates no cargo can justify. And that is the honest frame around every vehicle we have boarded so far. 100,000 light years is not a distance that better engines make reasonable. It is a distance that arithmetic itself declines to finance. The walk was absurd by time. The perfect starship is absurd by fuel. The line between those two absurdities is where all real spacecraft live, and none of them, not one machine, launched or imagined, chemical or perfect, brings the crossing into the length of a civilization, let alone a life. So we stop asking what we could send. We turn instead to the travelers that make the trip without asking permission, because the crossing is not hypothetical. It is happening now, tonight, in enormous numbers, and it has been happening for as long as the galaxy has existed. Light crosses the Milky Way. It does so routinely, indifferently, in every direction, all the time. A photon released at one rim of the disk, flying flat along the plane, completes the full 100,000 light-year line in 100,000 years. Nothing in the universe does better. The speed of light is not a record to be broken. It is the structure of the racetrack itself. 100,000 years is worth sitting with because it is the first travel time tonight that a human mind can almost hold. It is not trillions. It is not hundreds of millions. It is a number with a human echo, and that echo is what makes it devastating. Notice, too, that the mail runs in both directions. While ancient light arrives here, our own light is out there, mid-crossing. The sunlight that fell on the pyramids while their limestone was still white left the neighborhood long ago and is now more than 4,000 light years out, sweeping past stars whose planets, if any watcher stood on them, could in principle catch our star as it looked in the age of the pharaohs. Every photon the sun has shed in 4.5 billion years is still in flight somewhere. A sphere of biography expanding at the only speed there is, the outermost shells now well beyond the galaxy itself. Nothing about the crossing is hypothetical to light. The galaxy is crisscrossed, saturated, in every direction and at every moment by journeys of exactly the kind we cannot make. Consider a photon that finishes its crossing tonight, arriving at Earth after 100 millennia in flight, and run its departure backward. When it left the far rim of the galaxy, there were human beings on Earth. That is the astonishing part, but they were not us in any sense that survives the distance. They were small bands of hunters in an Ice Age world, sharing the planet with mammoths and with other kinds of human that no longer exist. No wheat had been planted. No animal had been tamed. No wall, no city, no letter, no name. Every single thing you could point to in your life, the language you think in, the country you live in, the alphabet these words were written in, agriculture itself, was invented while that one photon was in transit. It departed from a wild planet and arrived at this one, and the entire span of what we call history fits inside the final 5% of its flight. That is what 100,000 light years means. Not a big number, a span that contains the whole career of our species, with room left over, and light, the fastest traveler that can exist, must spend all of it, every year, to get across just once. Since the photon's departure date keeps returning tonight, it has earned a fuller portrait. Set the scene properly. Earth, 100,000 years ago, the evening our arriving light left the far rim. The planet is deep in an ice age. Great sheets of ice in places kilometers thick are building across the northern continents. So much of the world's water is locked into them that the oceans stand far lower than tonight's tide lines, and the map of the coast is drawn differently. Land bridges exposed, islands joined, shorelines that no modern chart records. The nights are dark in a way no living person has experienced. No flame beyond the campfire, no glow on any horizon. The Milky Way's band overhead so vivid it casts the faintest of shadows. The sky is the same sky, but the Dipper's stars ride in a subtly different pattern, and nobody alive beneath them has yet drawn a dipper or a hunter, or named a single constellation that history would remember. And the extraordinary fact of that evening is this: humanity is home, but we are not alone. Anatomically modern humans, people with your skeleton, your brain, your gaze, live in Africa, and some bands are beginning to probe beyond it. But across Europe and Western Asia, the firelight belongs to the Neanderthals, a separate human species, stockier, cold-adapted, burying their dead. Farther east, in the mountains and forests of Asia, live the Denisovans, a people so elusive we know them mainly from fragments of bone and the traces they left in living DNA. On at least one island chain, still other small-statured humans may persist. 4 kinds of human being, perhaps more, sharing one ice age planet. A crowded family portrait that will thin in the millennia our photon spends in transit to a single surviving line, us. Nothing about that world survives except what is carried in bodies and starlight. Every other human species will be gone within the photon's first half of travel. The ice will advance, peak, and collapse. The seas will rise and redraw every coast, and in the final 20th of the flight, the survivors will invent, in order, farms, towns, writing, history, telescopes, and the question this episode is asking. The photon left that Earth. It arrives at this one tonight. The distance it crossed is the same 100,000 light years we keep failing to cross in the other direction. And now you know precisely what the number costs in worlds. When a single beam of light outlives 4 species of human being in transit, the galaxy is not far. The galaxy is long. There are no shortcuts hiding here either. Light is not straining. Light moves at the only speed it can move, the maximum the universe permits, and the galaxy still bills it 100 millennia for the trip. When the fastest possible traveler needs that long, the word far has finished doing its work. What remains is stranger. Because from the photon's own side of the ledger, if we may borrow one carefully, the journey looks nothing like this at all. Relativity keeps a strange ledger for those who move quickly, and for light, it keeps the strangest ledger of all, an empty one. Physicists are careful here, and we will be careful too. Strictly speaking, a photon does not have a point of view. The equations of relativity refuse to build a valid observer moving at exactly the speed of light. And so the question, what does the trip feel like for the photon, has no rigorous answer. But the equations do let us watch what happens as a traveler approaches that speed, closer and closer, and the trend they show is unambiguous. The faster the traveler moves, the less time passes on board for the same journey. The crossing that takes 100,000 years by the galaxy's clock takes less on the ship, then much less. Then, as the speed of light comes within reach, almost none at all. Follow the trend to its unreachable edge, and the flight of our photon compresses towards zero. 100 millennia by every clock in the galaxy. Ice ages, extinctions, the whole invention of the human world, and on the traveler's side of the ledger, no time at all. Departure and arrival pressed together, a journey of 100,000 light years, experienced as nothing whatsoever. Sit with the asymmetry because it is the hinge of the whole night. The duration of the crossing is not a fixed fact about the galaxy. It is a negotiation between the traveler and everyone left behind, and the two parties are given different bills. The galaxy's clocks demand 100,000 years, and that demand is absolute, non-negotiable, and paid in full by the waiting universe. The traveler's clock is the only one that bends. Nothing made of matter can reach light's edge of the ledger, but matter can approach it, and that single fact, buried in equations written down more than a century ago, is the loophole this episode promised you. We will pry it open before the night ends. First, though, the sky over your head deserves its moment, because the crossings finishing up there tonight are not hypothetical, and you have been watching them your whole life without being told. Step outside tonight, or simply picture it. A clear night, away from streetlights, the pale band of the Milky Way tilted across the dark. Every point of light in that band is a delivery completed. The photons entering your eyes left their stars decades ago, centuries ago, millennia ago, and have been in unbroken flight ever since, through the plane of the disk, past star after star, dust lane after dust lane, to end their journey on the back wall of your eye. You do not see the galaxy, you receive it. Vision at these distances is a postal service with a very old backlog. Most of what you can see with unaided eyes lies within a few thousand light years, our own neighborhood's mail. But point a modest backyard telescope toward the constellation of the Archer, toward the bright, crowded core of the band, and some of the light you collect set out from the galaxy's far side and central regions tens of thousands of years ago. Photons that departed while glaciers stood a mile thick over Chicago are finishing their crossing tonight inside an amateur telescope on a suburban lawn. The distance we have spent all night failing to cross with machines is being crossed, in the other direction, into your eye continuously. And one arrival outranks all of these. On a truly dark autumn night, you can see a small, elongated smudge in the constellation Andromeda, the most distant object visible to ordinary human eyes. That smudge is not a star in our galaxy. It is another galaxy entirely, and its light has been traveling for 2.5 million years, 25 of our full crossings, laid end to end, completed by every photon that reaches you from it. When that light departed, no human being existed. Our ancestors were another species, on another continent's plains, and the light was already halfway here before anyone lit the first fire. The universe, in other words, completes these journeys constantly, casually, in volume. The crossing that defeats every machine we can imagine is ordinary physics for light, and it turns out for heavier travelers too. Because you are not standing still while you watch, the ground under your bed is aboard a vehicle of its own, and it has been quietly making laps of the entire galaxy since before your planet had a moon. The sun is in transit. It always has been. Along with every planet it holds, the sun is traveling around the center of the Milky Way at about 515,000 miles per hour, some 230 kilometers every second. You are moving at that speed now. You will be moving at that speed all night, and no part of you can feel it because everything you know, the bed, the house, the moon, the other planets, the nearest stars in the sky, is moving with you, carried in the same great current. The galaxy does not rattle. The ride is 4.5 billion years old and has never once been felt. At 230 kilometers per second, the sun is faster than anything in tonight's episode except light itself. It outruns Voyager 13 times over. It outruns Parker's record. It is, by an enormous margin, the fastest vehicle you will ever ride. Since this episode began, it has carried you well over 500,000 kilometers, farther than the distance from the Earth to the moon, while you lay still. And the ride is not even perfectly level. On its long circuit, the sun drifts gently above and below the galaxy's midplane, a slow bobbing measured in tens of millions of years per cycle, so that our whole planetary system rises through the starry disk and settles back like a carousel horse of unreasonable size. Nothing spills. Nothing ever has. At that speed, one full circuit of the galaxy, one complete lap around the crowd of a few 100 billion stars, takes about 230 million years. Astronomers call that span a galactic year, and it is the grandest calendar a human being can be placed on. 1 galactic year ago tonight, the first dinosaurs were appearing on a single supercontinent, and the Atlantic Ocean had not yet opened. That entire story, The rise of the dinosaurs, their 160 million year reign, the asteroid, the mammals, the primates, the ice ages, us, fits inside one lap. The sun has now completed roughly 20 such laps since it ignited. 20 galactic years old. In the time it took our star to make its most recent orbit, life on Earth went from lizards the size of house cats to a species that measures the orbit. So the fastest vehicle available to you is the one you were born aboard, and it is worth asking what its speed actually purchases against the line we are trying to cross, because the answer recalibrates everything. 230 kilometers per second sounds unanswerable. Here's what it comes to. Since the invention of writing, since the very first wedge-shaped marks were pressed into wet clay in the city of Uruk 5,000 years ago, the beginning of every recorded thing, the sun has carried the Earth about 4 light years through the galaxy. 4. All of recorded history, every empire, every library, every voyage, every night anyone has ever slept, corresponds to a distance our star could tuck inside the gap between us and Proxima Centauri, with room to spare. The pyramids to tonight, not quite one step to the nearest neighboring star. On a 100,000 light-year map, the entire human story so far, aboard the fastest ship any of us will ever ride, is a line too short to draw. And here's the thing worth saying plainly about it. The sun's speed is not disappointing. The sun's speed is tremendous. It is the distance that is out of category. When 5 millennia of travel at 500,000 miles per hour amounts to a rounding error on the map, the lesson is not that we need a faster star. The lesson is that the map operates on a different clock than biography, or history, or even species. The galaxy keeps time in galactic years, 230 million to the tick, and it is entirely indifferent to the fact that its passengers live and die 10 million times faster than that. Indifferent, but not sealed. Because the galaxy has passengers that do leave. Among the few 100 billion stars riding these same orderly orbits, a handful have been thrown clean off the carousel, flung outward at speeds no planet-bound imagination would assign to something the size of a sun. One of them was caught in the act only a few years ago, and its story carries our question, how long to cross? To the most extreme speed matter has ever been observed to hold in our galaxy's disk and halo neighborhood. In 2019, a survey team led by astronomer Sergei Kapusov, sifting data from a Southern Sky project and the Gaia Space Observatory, found a star in the constellation of the Crane that had no business moving the way it was moving. It is cataloged as S5HVS1, an ordinary young star about twice the mass of the Sun, and it is leaving the galaxy at 1,755 kilometers per second, nearly 4 million miles per hour, 8 times the Sun's orbital speed. It is the fastest main sequence star ever measured in the Milky Way, and it is not orbiting anything anymore. It is unbound, moving too quickly for the combined gravity of a few 100 billion stars to ever call it back. The remarkable part is that we know exactly who threw it. Run the star's trajectory backward, and it points like an accusation at one address, the precise center of the galaxy. About 4.8 million years ago, S5H5S1 was one half of a binary pair, 2 stars orbiting each other, that wandered too close to the central black hole. The encounter has a name, the Hills mechanism, proposed decades before anyone saw it happen. The black hole's gravity tears the pair apart, captures one star into a tight, doomed orbit, and hurls the other away with the stolen energy. One sibling kept, one sibling thrown. The thrown one has been climbing out of the galaxy ever since, a bystander to a gravitational transaction it did not choose, carrying in its speed the exact record of its partner's capture. Now give our question to the fastest thrown object the galaxy has produced. At S5HV S1 speed, the full 100,000 light-year crossing takes about 17 million years. 17 million. The champion, a star flung by a supermassive black hole at the most extreme measured pace in the Milky Way, still needs 3,000 times the length of recorded history to cross the map. It will not finish its own escape for millions of years yet. When it finally leaves the galaxy's grip entirely, it will drift into intergalactic darkness, cooling through its lifespan alone, with no destination ahead of it at any distance its lifetime can reach. Even the galaxy's own violence, in other words, cannot really send anything across the galaxy. It can only send things out, and the engine of that violence, the thrower itself, is worth a chapter of its own because everything in tonight's episode, every orbit, every lap, every thrown star, ultimately turns around it. At the exact center of the map, 26,000 light years from your bedroom, there is a region where the stars crowd together 1,000,000 times more densely than they do in our neighborhood. And at the center of that crowd, there is an object with no surface, no light, and the mass of 4.3 million suns. It is called Sagittarius A star, written with an asterisk that astronomers pronounce as star, a name far too clerical for what it labels. It is the Milky Way's central supermassive black hole. For decades, its existence was inferred rather than seen. Astronomers watched stars near the galactic center whip through complete orbits in mere years. One of them, called S2, dives within about 12 billion miles of the invisible point at several thousand kilometers per second. And only one kind of object could anchor such orbits while emitting almost nothing. The bookkeeping demanded 4 million solar masses packed into a space smaller than our planetary system. Only a black hole fits that description. Then, in May 2022, the Event Horizon Telescope collaboration, a network of radio observatories spread across the Earth, operating together as a single planet-sized instrument, released an image of it. A ring of glowing orbiting gas bent by gravity wrapped around a central shadow, the shadow of the thing itself. It was the first time our species looked directly at the object every star in our sky ultimately circles. Here's the correction the image quietly delivers. Sagittarius A star does not hold the galaxy together. Its 4 million solar masses, for all their local ferocity, are a rounding error against the hundreds of billions of stars, and the far larger halo of unseen matter, whose combined gravity actually shepherds the sun through its 230 million year lapse. The black hole is not the galaxy's engine. It is the galaxy's still point, the marker at the middle of the carousel around which everything is arranged, but by which almost nothing is pulled. The sun does not orbit Sagittarius A star any more than a ship crossing the Pacific orbits the buoy at its center. And yet, for our journey, the center matters in a different way. Any straight crossing of the full disk passes through the galaxy's crowded interior, through fields of stars packed shoulder to shoulder by our suburban standards, past the dense nuclear cluster, near the one object in the Milky Way that has demonstrated, with S5HVS1 as its receipt, what it does to travelers who come too close. The middle of the line is not empty road. It is the deep interior of a metropolis, and the traveler's map marks it the way old charts marked reefs. 26,000 light years from here to that still point. The same distance again to the far rim. And since any full crossing must pass that deep interior, the traveler's map owes us one more chapter about what the middle of the line is actually like, because it is like nothing in our sky. Out here in the Orion Arm, the stars keep a courteous suburban spacing. One household, then 4 light years of dark, then the next. The galaxy's central regions never heard of such manners. Within the innermost few light years around Sagittarius A star, surveys count stars packed roughly 1,000,000 times more densely than in our neighborhood. 1,000,000 times. If our local spacing is a town where each family owns a valley, the galactic center is a single apartment tower with every window lit. Thousands of suns inside volumes that here would hold one or none. Stars there miss each other by light weeks and light days rather than light years. Close encounters, vanishingly rare in our suburb, are routine enough there to reshape orbits, strip away infant planetary systems, and, as one thrown star testified earlier tonight, occasionally hurl a resident out of the galaxy altogether. Stand, in imagination only, on some airless world deep in that district, and the night sky stops being a scatter of points. It becomes a ceiling of lamps, hundreds of thousands of stars brighter than anything in Earth's sky, many outshining Venus, dozens rivaling the full moon. A sky so bright that true darkness never falls, so crowded that the familiar act of picking out constellations becomes absurd, like naming patterns in falling snow. The dust lanes that veil the center from our telescopes would hang overhead as glowing backlit banks. It would be, by every account astronomy can assemble, the most magnificent sky the galaxy offers, and among the least restful. For the crossing, the middle is therefore both the journey's spectacle and its gauntlet. The traveler's straight line passes through radiation fields, far harsher than our sheltered arm endures, through gravitational currents stirred by millions of crowded suns, and past the one address where the toll for a navigational error is captured by a 4 million solar mass accountant. Mission planners of some far century may well route around the core entirely, accepting extra millennia the way sailors once accepted the long way around a cape. The center, in other words, is not the halfway marker of the line. It is the line's one great city, dense, brilliant, dangerous, unsleeping, with 50,000 light years of quiet country road on either side. Having looked at the road and its capital, it is time to plant tonight's anchor a second way, using the only signal our species has actually sent into any of it. Set aside vehicles for a moment. Ask instead how far humanity itself, not our machines, but our presence, has actually reached into the 100,000 light years we keep measuring. The honest answer is a sphere of radio noise. Since the first transmissions crackled out of spark gap antennas around the turn of the 20th century, Marconi's transatlantic signal crossed the ocean in 1901. Our broadcasts have been leaking off the planet at the speed of light, expanding outward in all directions, a bubble of voices growing 1 light-year larger in radius every year. Radio drama, then television, then radar, then everything. The oldest edge of that bubble is now roughly 125 light-years out. 125 light-years against a disk 100,000 light-years wide. Our loudest century, the entire electromagnetic career of our species, has filled about 1/10 of 1% of the galaxy's width. Drawn on the full map, the bubble that contains every word humanity has ever broadcast is smaller, proportionally, than a soap film resting on the Pacific. Inside that film, every radio show, every moon landing broadcast, every song ever transmitted. Outside it, the other 99.9% of the Milky Way, which has never received any evidence that we exist. And the honesty must go one step further, because even that thin film overstates us. Radio waves obey the inverse square law. A signal's strength falls off with the square of its distance, and our broadcasts were never aimed, only spilled. In 2023, researchers at the University of Manchester, working with the SETI Institute, modeled the leakage from Earth's mobile phone towers and found that a civilization with a radio telescope as capable as our best could not detect it even from the nearest stars, a few light years away. The bubble is real, but it is a whisper thinning towards silence. By the time our century of noise reaches even its own modest edge, it is fainter than the static of the stars themselves. This is the second planting of tonight's anchor, and it may be the most humbling version. 100,000 light-years is a distance our species has not crossed with so much as a detectable murmur. We have not moved across the line. We have not been heard across the line. On the scale of the map, humanity has so far amounted to a point, a bright, busy, self-aware point, aboard a star making its 20th lap, unheard beyond the nearest room of the house. Every crossing we have attempted tonight has run the long way, edge to edge through the disk. But the Milky Way has a short direction too, and it changes the picture in a way most star maps never mention. The disk is wide, but it is astonishingly flat. Its bright span runs 100,000 light-years across, yet the main stellar disk is only on the order of 1,000 light-years thick, a ratio of about 100 to 1, the proportions not of a ball but of a sheet. For every 100 steps the long crossing demands, the short crossing demands 1. A traveler who abandoned the Great Line and instead flew straight up, out of the plane of the disk, would leave the galaxy's bright neighborhoods after roughly 1,000 light-years, a journey light manages in a single millennium, the span from the Vikings to the present. The catch is the destination. Above the disk, there is no far shore. There is the halo, a vast, dim, roughly spherical region wrapped around the bright galaxy, scattered with the Milky Way's oldest residents. Ancient globular clusters, dense, glittering spheres of hundreds of thousands of stars apiece, some nearly as old as the universe, drift through the halo on long tilted orbits, along with thin streams of stars torn from smaller galaxies our Milky Way has swallowed over the eons. The halo is not empty, but it is sparse beyond easy description, and it simply fades, stars thinning, then thinning again into the true intergalactic dark. So the short crossing is real, and it is even almost achievable. 1,000 light-years is only 10 of our radio bubbles laid in a row. But it is an exit, not an arrival. Climb out of the disk, and what you reach is a balcony over the galaxy. The whole 100,000 light-year spiral spread below you, arms and dust lanes and glowing core, the single most extraordinary view physics permits in our corner of the universe, with nothing ahead but a fall into darkness that continues, effectively, forever. The galaxy, it turns out, is easy to leave and impossible to cross. Every direction out is short. Every direction across is 100 millennia at the speed of light. And for anything slower than light, for anything made of matter with a hull and a cargo and an intention, the crossing has one more obstacle we have politely ignored all night. The road itself is not clear. Between the stars, the galaxy keeps weather of its own, and at the speeds a real crossing would demand, that weather becomes a wall. Interstellar space is called a vacuum, and by every laboratory standard, it is one, emptier than the best vacuum chambers on Earth, a few atoms drifting in each thimble of space. But empty is a speed-dependent word. A road with 1 pebble per mile is empty at a walking pace. At 100,000 miles per second, it is a firing range. The space between the stars carries a thin tissue of gas, mostly hydrogen, threaded with microscopic grains of dust, fragments of carbon and silicate, soot and sand on the smallest possible scale, shed by dying stars and scattered through the disk. You have seen this tissue with your own eyes, whether you knew it or not. The dark rifts that split the Milky Way's band on a clear night are not gaps in the stars. They are dust lanes, clouds of this material, dense enough to blot out the starlight behind them. The road across the galaxy runs straight through weather like that. For our slow machines, the dust is nothing. Voyager 1 has been flying through it for 49 years and has simply grown a faint patina. But the crossing we keep imagining is not slow, and speed transforms the road. In 2017, a team of astrophysicists, Tai Huang, Alexander Lazarian, Blakesley Burkhart, and Abraham Loeb, published a careful accounting of what interstellar matter does to a spacecraft at relativistic speed, prompted by a real proposal to send probes to the nearest star at 1/5 of the speed of light. Their result? Over just the 4 light years to Alpha Centauri, ordinary interstellar dust would erode roughly 0.5 millimeter from every forward-facing surface, and the gas alone would damage a further 1/10 of a millimeter. Each microscopic grain at that speed strikes with the energy of a rifle round concentrated into a pinpoint. And the faster the ship, the harder the weather. Closer to the speed of light, a collision with a single sand grain-sized particle releases the energy of a bomb. 0.5 millimeter of armor lost in 4 light years, and our line is 100,000. Scale the erosion up, and the arithmetic turns any unshielded hull into vapor long before the journey's midpoint. A real crossing would need armor, or shields, or some way of sweeping the road that nobody has designed against a hail of impacts continuing not for years, but for millennia. The picture then is complete and honest. The distance defeats our engines. The fuel defeats our bookkeeping. The road itself defeats our materials. And yet our species, knowing all of this, has already mailed 4 letters into the crossing anyway, which may be the most quietly human fact in tonight's entire ledger. Drifting outward through the galaxy tonight are exactly 4 human artifacts on interstellar trajectories: Pioneer 10, Pioneer 11, and the 2 Voyagers. and every one of them carries a message composed for readers who almost certainly do not exist. The pioneers, launched first in the early 1970s, each carry a small gold anodized plaque, an engraving of a man and a woman, a diagram of the solar system, and a map of pulsars, those lighthouse stars we will not dwell on tonight, triangulating the position of the sun. The Voyagers carry something far more ambitious, the Golden Record, a gold-plated copper phonograph disc assembled in 1977 by a committee led by the astronomer Carl Sagan. On it, greetings spoken in dozens of human languages, the sounds of surf and thunder and heartbeat and laughter, photographs encoded in its grooves, and 90 minutes of music. Bach and Chuck Berry, gamelan and blues, the planet's mixtape, sealed under an engraved cover that diagrams, for any finder, how to build the machine that plays it. No one expects delivery. Space is too empty and the letters are too slow. In about 40,000 years, Voyager 1 will make its closest approach to another star. And closest means drifting past at more than a light year's distance, a letter blowing down a street with no houses. The engineers who plated the record chose their materials accordingly. Shielded from dust and cosmic rays only by distance and gold, the disc is expected to remain playable for perhaps 1 billion years. 1 billion. The letter is built to outlast its author's species, plausibly its author's planet. Sound waiting in copper long after the voices, the surf, and the shoreline itself are gone. Understand what the 4 letters really are, measured against tonight's line. They will cross no meaningful fraction of it. They are not transportation. They are testimony. The crossing reimagined as a message in a bottle, thrown by a species that could not make the voyage and refused to say nothing. Every civilization's reach exceeds its grasp somewhere. Ours exceeds it here by roughly 100,000 light years, and we mailed the difference. Which is why, when our species seriously discusses actually sending itself, the conversation stops talking about speed and starts talking about time. About patience on a scale no single life can supply. About ships that are not vehicles at all, but worlds. That idea deserves its own chapter, because it is the most humanly serious answer anyone has proposed, and tonight, at galactic scale, we are going to watch it break. The idea is called a generation ship, and it begins with a concession no other spacecraft has ever made. The admission that the passengers who arrive will not be the passengers who left. Abandon speed. Accept centuries. Build a vessel so large and so complete that it works as a small sealed world. Farmland under artificial light, water cycling through closed loops, air scrubbed and renewed by machinery and by growing things. A population in the thousands, born aboard, living aboard, buried aboard. The ship becomes a village with a destination. Engineers have sketched such vessels seriously since the middle of the 20th century. Slow, vast, patient arcs that trade the impossible demand for velocity against the merely heartbreaking demand for continuity. Nothing about the concept violates physics. That is precisely what makes it the most serious proposal on the table, and the standard against which the galaxy's size becomes most vivid. Because every serious generation ship study ever drafted aims at one star. One, The nearest worthwhile destinations sit a handful of light years away. Proxima Centauri at 4.25, a scatter of promising systems within 10 or 20, and at the few percent of light speed such a vessel might realistically sustain. Even those neighborly gaps demand voyages of many centuries. 1,000 years to a nearby star is the optimistic version. The plans grow hushed and hypothetical well before they reach 50 light years. Our line is 100,000. Point the most ambitious arc ever imagined along the full crossing at generation ship speeds, and the voyage does not take centuries. It takes on the order of a few million years. The ship's own portion of the arithmetic we granted Parker and the Throne Star earlier tonight. A few million years is not a long voyage. It is an evolutionary epoch. It is the span that separates you from the small, upright creatures on the plains of Africa, whose bones we now excavate and study through glass. A crew that boarded such a ship would not deliver descendants to the far rim. It would deliver a different species, if it delivered anything at all. And long before biology rewrote the passengers, a quieter failure would have unmade the voyage itself. Not the hull, not the reactor, the cargo that never appears on any engineering diagram. Memory, meaning, and purpose. That cargo has a shelf life, and it is the next chapter of the night. Grant the ark every mechanical mercy. The hull holds. The crops never fail. The water stays clean for 100,000 years of the slower, honest crossing. Now count the passengers. At roughly 25 years to a human generation, 100,000-year voyage carries about 4,000 generations from departure to arrival. 4,000 successive worlds of parents and children, each born into the corridor light, each taught the mission by people who were themselves taught it, each teaching it onward to children for whom the departure planet is not a memory but a myth. Hold that chain up against the oldest continuities our species has actually managed. The pyramids at Giza stand about 4,500 years behind us, 180 generations, give or take. And in that time, the language of their builders died, the religion that raised them dissolved, and the ability to read their writing was lost for nearly 2 millennia until a chance-found stone restored it. 180 generations were enough to sever nearly every thread. The Ark asks for 4,000. No language survives such a span. Linguists watch tongues drift into mutual strangeness within mere centuries. Across 100 millennia, the crew's speech would be rewritten 20 times over, and the mission briefings of the founders would become inscriptions in a dead script, curated, perhaps worshipped, no longer understood. No institution survives it either. Every government, church, and academy aboard would be younger than the voyage, most of them younger than a single % of it. Somewhere in the long middle, deep in the numberless decks, the destination itself would quietly change category, from a place the ship is going to a story the ship tells, to a heresy some deck-born generation finally stops telling. The founders could write their purpose into law, into ritual, into the very architecture. The pyramid builders did the same. Stone outlasted meaning by 45 centuries and counting. This is what the galaxy's width does to the most patient plan our species has ever drawn. It does not break the ship. It breaks the story the ship was built to carry. A generation ship, at galactic range is a message written in a language guaranteed to die in transit. Humanity's grandest sentence, addressed to no one who will be able to read it. So the slow road fails not at engineering, but at meaning, which drives the discussion toward the stranger cargo manifests, the proposals that stop trying to keep a civilization awake for the trip and start trying to make the trip without one. Once the living crew is recognized as the weak component, the proposals become quieter and stranger, and it is worth walking through them honestly because each one trades away a little more of what crossing was supposed to mean. The first trade is consciousness. Suspended animation. The crew cooled or chemically stilled into something like the torpor of hibernating animals, aging slowly if at all, sleeping through the centuries while the ship keeps house. Medicine has real footholds here. Surgeons already chill patients into brief survivable pauses, and hibernating mammals demonstrate that biology can idle far below its normal burn. But the footholds are hours and months. The proposal is centuries, then millennia, and unbroken maintenance of fragile tissue against radiation, decay, and the ship's own aging machinery, for spans longer than most civilizations have lasted. It remains, stated plainly, unsolved. And even granted in full, at galactic range the sleepers merely arrive as strangers, people of a world 100,000 years gone, waking into a galaxy that has moved on without them. The second trade is the crew itself. Seed ships, vessels carrying no travelers at all, only the beginnings of travelers, frozen embryos or genetic libraries tended by automated systems that would raise the first generation at the destination. Machines as midwives and parents, a century of childhood administered by software, a human culture rebooted from files. The mass to accelerate shrinks wonderfully. What grows in its place is a question no engineering document can close, whether what steps out of such a vessel, raised by no one, heir to a recorded civilization it never touched, is a continuation of us in any sense the founders intended, or a new people altogether, wearing our genome. The third trade is humanity itself. Send only machines, probes that need no air, no sleep, no meaning, patient in a way no crew can be. This one, at least, our species has already begun. Voyager 1 is exactly such an emissary, mute and coasting, with its golden record of greetings bolted to the hull. Machines will make the first crossings, if crossings are ever made. But notice what has happened to the question. A robot completing the line 1,000,000 years from now does not carry anyone across the galaxy. It carries the fact that we once existed. A postcard, not a passage. Sleepers, seeds, and machines. Each proposal survives the distance by discarding another piece of the traveler until what arrives is no longer the one who wanted to go. At galactic range, the slow roads all end in the same quiet place, the crossing completed, and no one aboard to know it. Which leaves one road left, the strange one. The one that does not fight time with patience, but bends time itself. And it has been waiting in the mathematics all night, ever since we noticed that the traveler's clock is the only clock that yields. The loophole begins with the most ordinary sensation you know. Wait. Imagine a ship that does something almost laughably simple. It accelerates gently and never stops. Not a violent launch, no crushing thrust. 1G, 9.8 meters per second of new speed added every second. Exactly the acceleration your own body is built for, the pull you are feeling from your mattress at this moment. Aboard such a ship, there is no floating, no straps, no exercise machines fighting bone loss. The engine's steady push is indistinguishable from gravity. Einstein himself made that equivalence the cornerstone of his theory. And so the ship simply has a floor. Coffee pours. Children skip rope. The crew lives in ordinary weight aboard a vessel that is, in effect, falling forward through the galaxy forever. Nothing about this sounds extreme, and that is the trick of it, because 1G, sustained, compounds the way patience never can. After a day of falling forward, the ship is moving faster than any spacecraft we have ever flown. Within weeks, it has left every record in this episode far behind. And somewhere around the 1-year mark, the ship's speed approaches the speed of light itself. Approaches, never reaches. And the equations we met with the photon begin to apply to human beings. Relativity then does two things at once, both strictly verified in every laboratory and particle accelerator that has ever tested them. To the galaxy, the ship becomes one more traveler crawling along at just under light speed, due at the far rim in 100,000 years, no exceptions granted. But aboard the ship, time itself runs slower relative to the galaxy outside. Not as illusion, not as frozen sleep, but as genuine, ordinary lived time, compressed by motion. The crew feels nothing unusual. Clocks tick, bread rises. The compression is invisible from inside, and it deepens relentlessly as the speed climbs, 1G month after month, year after year. Halfway across, the ship turns around and points its engine forward, falling backward now, 1G of gentle braking, so that it slows in time to arrive rather than streak through the destination at the edge of light speed. Accelerate half the way, decelerate half the way, ordinary weight throughout. That is the whole flight plan. It is the least dramatic itinerary in this episode. Before the full arithmetic, watch the compounding work, because the first year aboard this gentle ship is one long, quiet demolition of every record in tonight's episode. Day 1. 24 hours of falling forward at the weight of home, and the ship is moving at about 847 kilometers per second. Read that against the night's honor roll. More than 4 times the Parker Solar Probe's all-time record, set in a screaming dive through the sun's gravity, matched and quadrupled by a vessel whose passengers have felt nothing but a floor. 50 times Voyager's pace. One day. Day 2 doubles nothing dramatic. It simply adds another day's worth. That is the whole character of the machine. No events, no burns, no milestones announced. Just addition, hour upon hour, of speed that no crew member can feel. By the end of the first week, the ship is passing 6,000 kilometers per second, 2% of the speed of light, and the Throne Star S5HVS-1, the fastest object the galaxy itself has ever been caught hurling, falls behind the tally like a local train overtaken by an express. Within the first month, roughly 8% of the speed. Every velocity record held by every natural and artificial object in the Milky Way suburbs surpassed inside 30 days of what feels, aboard, like standing still in a hallway. Around the 1-year mark, the addition runs into the universe's speed limit, and relativity begins folding the gains inward. the ship approaching, never reaching, the pace of light, at roughly 3/4 of it as the first year closes, with a bit more than half a light year behind the stern. And here the strangeness turns domestic. The crew has spent one ordinary year, 365 breakfasts, a birthday each. But the compression has begun. Their clocks and the galaxies have started to disagree, gently at first, then not gently. And every further month of falling widens the disagreement, buying distance with other people's time at an accelerating exchange rate. 1 year from a standing start at the acceleration your mattress is applying to you right now. That is all it takes to retire every record in this episode and stand at the threshold where clocks part company. The rest of the voyage is that same quiet process, continued, and the arithmetic it produces is the single most extraordinary number of the night. The equations for such a voyage were worked out long ago and sit today in physics references anyone can check. Take the relativistic rocket at 1g, accelerating to midpoint and braking to rest. Ask it our question, 100,000 light years, edge of the galaxy to edge of the galaxy. The galaxy's clocks, as always, will charge just over 100,000 years for the trip. The ship's clocks charge 22. 22 years, not 22,000. 22, the span from a birth to a graduation. A crew that boarded in their 30s would step off at the far rim in their 50s, having lived every day of the voyage in ordinary weight, under ordinary light, aging at what felt like an ordinary pace. The crossing that takes light itself 100 millennia, that would consume 4,000 generations aboard the Ark, that exceeds the entire span of the recorded history 20 times over. Completed within one career. Younger crew members could make the crossing, turn around, and cross back twice within a single long human life. The number sounds like an error, so it is worth seeing why it is not. The compression compounds. At 1g, each year aboard buys enormously more distance than the year before, because the ship rides ever closer to light speed while its onboard time thins relative to the galaxies. The first year of falling forward carries the crew about half a light year. By midpoint, single ship years are sweeping past tens of thousands of light years of stars. Distance for a 1g traveler stops being the thing that takes time. It becomes the thing that pours past while modest human amounts of time elapse aboard. The relativistic ledger from the photons chapter. Applied to people. The traveler's clock yields, and it yields exponentially. Push the same equations further, and they say something almost indecent. At a sustained 1g, the Andromeda Galaxy, 2.5 million light years out, lies about 28 ship years away. The edge of the observable universe, in principle, under 45. A single human lifetime, one set of hands, one continuous falling forward, could in the mathematics outlast every distance the night sky contains. The galaxy, which defeated every machine, every fuel tank, every ark, and every sleeper, does yield to a ship we cannot build on terms we have not yet stated. The terms are the heart of it. But first, spend one chapter at the window of this impossible ship, because what the crew would see during those 22 years is one of the strangest verified predictions in all of physics. Begin the voyage at the observation window, and for the first months, the galaxy looks as it should. the same constellations, the same slow river of stars, the ship's speed still small against the speed of the light bringing the view. Then the compression starts to show. Not in the clocks, which seem normal aboard, but in the sky itself. The first change is position. As the ship's speed climbs toward lights, the light arriving from every direction is bent forward by the ship's own motion, an effect called relativistic aberration, kin to the way falling rain seems to slant toward a moving car's windshield. Stars that lay abeam begin to drift ahead. Stars behind creep around the flanks. The whole celestial sphere flows slowly toward the bow, gathering, crowding, until the sky ahead is congested with stars while the sky astern goes sparse and dark. Near the voyage's fastest stretch, most of the visible universe has pooled into a brilliant patch dead ahead, the galaxy compressed into a headlight, while behind the ship there spreads a growing blackness where the view used to be, as if the universe were politely closing the door the crew came in through. The second change is color. The ship's motion squeezes the light waves arriving from ahead and stretches the ones from behind, the Doppler shift. The same physics that raises the pitch of an approaching siren. Stars ahead blue shift. Reddish suns turn white. White suns turn sapphire and light that was never visible at all. The infrared glow of dust, eventually the deep microwave hum left over from the universe's beginning, is squeezed up into the visible band and pours through the forward window as new light with no earthly name. Astern, the last visible stars redden, ember out, and vanish into wavelengths no eye can catch. The crew flies toward a jeweled, violet-white blaze and away from a warm darkness, while A-beam, in the strange middle distances, the transiting galaxy streams past in shifted colors no planet-bound sky has ever shown. None of this is speculation. Aberration and Doppler shift are measured daily in accelerators and observatories. The 1G window pane simply turns settled equations into scenery. Physicists who compute the view in detail add practical footnotes. At the extreme, that forward blaze grows fierce enough to be a radiation problem rather than a vista. One more entry in the engineering ledger of impossibilities. But the shape of the experience stands. A crew crossing the galaxy at 1G would watch the universe fold its lights forward to meet them. 22 years of ordinary evenings at a window no one has ever stood behind. That is what the crossing would look like from inside. What it looks like from outside, from home, from everyone the crew ever knew, is the other half of the ledger. And the other half is the price. Here's what happens at home while the 1G ship makes its 22-year crossing. 100,000 years pass. Both numbers are true at once. That is the entire unsoftened content of relativity's bargain. 22 years aboard, 100 millennia ashore, and no appeal. The crew's compression of time is purchased exactly and irreversibly at the cost of everyone else's. The ship does not escape the 100,000 years. It roots them around the hull. Follow the bargain to its human floor. The crew departs on a Tuesday. Within the first ship decade, back on Earth, everyone they have ever met has died. Not tragically, simply in the ordinary way of time. Their children's children complete lives, and their children's children's children, while the crew stands watches and mends hydroponics through what feels like a single busy decade. By the voyage's midpoint, the departure has aged out of living memory, out of recorded history's horizon, out of language itself. Whatever now stands where the launch site stood, whatever now speaks where their language was spoken, it bears the same relation to the crew that we bear to the Ice Age hunters of the Photons chapter. People of 100,000 years ago, strangers in every particular. Even correspondence dies under the arithmetic. Suppose the crew, mid-crossing, beams a message home. A report, a farewell, a child's voice recorded in the hydroponics bay. The message travels at light speed, which is to say barely faster than the ship itself. It crawls back across the tens of thousands of light years already covered and arrives at an Earth that has aged accordingly, addressed to households tens of millennia dissolved. A reply, supposing anything replies, chases the ship for further tens of thousands of years and reaches the far rim long after the crew's arrival, or their deaths. Radio, the instant medium, the voice that made our planet feel small, becomes at this scale a correspondence between geological eras. The crew would live inside a 22-year voyage in which every letter home is addressed to the deep future, and every letter received is mail from the deep past. Silence, for the first time in human travel, would not be a failure of equipment. It would be the physics working correctly. And the door home is not merely closed. It is mathematical. Turn the ship around at the far rim, fall forward for another 22 shipboard years, and the crew returns to Earth having aged 44 years, to a planet on which 200,000 years have now passed. The return trip does not undo the bargain. It doubles it. Relativity offers the traveler any distance at 1g within a lifetime, and quietly writes in the terms and conditions that every such lifetime is one way. Not one way in space, one way in time. This is why the crossing has never truly been about propulsion, and why tonight's question, how long would it take, has been keeping two sets of books all along. 22 years is a real answer. 100,000 years is a real answer. They are answers to the same voyage, kept on clocks that motion has pried apart, and every crew that ever makes the crossing will have to choose which of the two numbers to live inside, knowing the other number is being paid in full by everyone they left at home. And here's the thing nobody likes to say plainly about crossing the Milky Way. The distance was never the real problem. Time is. Every obstacle tonight has secretly been this one wearing different clothes. The walking cascade was time. The ark's 4,000 generations were time. Even the fuel ledger was time in disguise. Energy is what buying speed costs, and speed is only the purchase of a shorter clock. When the 1G mathematics finally handed us a crossing that fits inside a life, it did not defeat the problem. It relocated it off the ship onto the world, onto everyone the traveler claims to be crossing for. The galaxy can be crossed. The century you belong to cannot come with you. Honesty requires the engineering coda, stated once and calmly. The 22-year ship is arithmetic, not blueprint. Holding 1G for years demands the fuel ledger's tons of perfect propellant per kilogram delivered, a figure no chemistry, no fission, no fusion approaches. At the Voyage's fastest stretch, the thin interstellar tissue arrives as radiation, even the universe's own background glow, blue shifted by the ship's speed, would press against the bow as a lethal furnace-bright headwind. The dust that sanded half a millimeter from a slow probe becomes, near light speed, a hail of detonations. Physicists who admire the equations are unambiguous about the machine. Nothing we know how to begin building begins to qualify. The loophole is real, and the door is real, and the key does not exist. So the honest inventory of the night stands like this. The galaxy is 100,000 light years wide. Light pays the toll in full. Matter can, in principle, cheat the clock aboard while the universe pays the difference outside. And our species tonight owns exactly one vessel in the crossing lane, a 49-year-old probe, one light day out, carrying a golden record and no one to play it. That is not a failure report. It is a map of where we actually stand. At the very beginning of the longest road there is, holding mathematics that says the road is passable and machinery that says not yet, not remotely, not for a very long time. What remains before we close the ledger is to widen the window one last time, because the 100,000 light-year line we have spent all night failing to cross is itself only the first tile of a much larger floor. 100,000 light years. The number has anchored every chapter of tonight. The walk, the probes, the bubble of our voices, the 22-year miracle and its terrible invoice. It has stood all night as the measure of the immense. So it is worth knowing, as the night begins to settle, what that number looks like from one step further back. It looks small. The nearest large galaxy to our own, the Great Spiral in Andromeda, lies about 2.5 million light years away. 25 of our full crossings, laid end to end, gap after gap of intergalactic darkness before the next major port. The line that defeats every vehicle our species has ever conceived, the line light itself pays 100 millennia to finish, fits into the space between our galaxy and its nearest peer 25 times over, like a handspan measured against a field. And Andromeda is the close one. Our Milky Way and it are the two great members of a small gravitational household astronomers called the Local Group. Dozens of galaxies, most of them dwarfs, drifting together through a region a few million light years wide, bound to one another, while the wider universe expands around them. Cross the entire Local Group and you have merely reached the edge of the household. Beyond it, the next great gathering, the enormous Virgo cluster of galaxies, lies tens of millions of light years out. Hundreds of our crossings, laid end to end, through darkness emptier than anything inside a galaxy's walls. Notice what the widening does to tonight's central number. Within its own disk, 100,000 light years is the total, the whole road, the final answer. On the intergalactic map, it is the unit, the single tile from which the larger distances are counted, the way a mile is counted from feet. The galaxy that has spent the night being an uncrossable ocean turns out to be, in the universe's own accounting, one drop of harbor water. The 1G equations, indifferent as ever, will quote a shipboard fare for these distances too. 28 years to Andromeda, they say, for a crew that can never come home. But the galaxy's clocks answer with millions of years, and the pattern of the whole night simply repeats at the next scale up unchanged. The floor is very large, The tiles are all the same kind, and ours, the one we live on, the one we have not crossed, is not even holding still beneath us. Because Andromeda, it turns out, is not merely our nearest great neighbor, it is our approaching one. Careful measurements of its light show the Andromeda Galaxy moving toward the Milky Way at roughly 110 kilometers per second, about 250,000 miles per hour, of closing speed between two spirals of hundreds of billions of stars each. The two galaxies are falling toward one another under their mutual gravity, slowly by any clock but the universe's own, and the fall has been underway since long before Earth existed. Projected forward, the encounter arrives on a horizon of roughly 4 to 5 billion years. Astronomers who model it are honest about the remaining uncertainties. The sideways component of Andromeda's drift is fiendishly hard to pin down, and recent studies still debate whether the first pass will be a direct collision or a wide, curving near miss, followed by a longer mutual orbit. But the general expectation has become one of astronomy's great quiet forecasts. On billion-year timescales, the Milky Way and Andromeda meet, sweep through and around one another, and over further billions of years settle together into a single, larger, calmer galaxy. Astronomers, unable to resist, already call the eventual merged household Milkomeda. The timing carries its own quiet poetry. 4 to 5 billion years from now is roughly the era when our own sun, its fuel spent, will be swelling toward the end of its long life. The star and the galaxy that carries it arriving at their great transitions together on the same unhurried calendar. Here's the detail worth carrying to sleep. When galaxies collide, their stars do not. The gaps between stars are so vast that 4 light-year handspan between us and Proxima, repeated hundreds of billions of times, that two entire galaxies can pass through one another with essentially no two suns ever striking. The collision is real, but it is a collision of architecture, not of objects. Spiral arms unravel, orbits scatter. The tidy disk we spent tonight measuring is stirred into a new shape around a new center. Any far future observers would see the night sky itself rearranged over millions of generations. Andromeda swelling from a smudge to a second Milky Way arched across the dark, then the two bands tangling into one. And with that, tonight's anchor number acquires an expiration date. 100,000 light years is the width of a structure that is, on the grandest calendar, temporary. The line we could not cross is scheduled for demolition. The traveler who waits long enough will not need to cross the Milky Way, because the Milky Way, given 5 billion years, is coming apart and reforming around everything it contains. Even without Andromeda's help, though, the map refuses to hold still on far shorter clocks. That restlessness is the next, gentler chapter. Suppose the 100,000-year crossing began tonight anyway. The slow, honest version, at light's own pace. Here is the quiet complication no itinerary survives. By the time the traveler arrived, the map they departed with would describe a galaxy that no longer exists in that arrangement. Every star in the Milky Way is in motion, each on its own orbit, each at its own pace. The constellations you know are not structures, they are coincidences. Chance alignments of unrelated stars at wildly different distances, photographed by one brief century of human attention. Astronomers measure the drift directly. The stars of the Big Dipper, mostly a loose family traveling together, are pulling slowly out of formation, and in 100,000 years, the Dipper's familiar ladle is bent past recognition, its handle splayed, its bowl collapsed into a shape with no name. Orion loses his belt. The Southern Cross uncrosses. Every pattern in every culture's sky, every figure sailors steered by and lovers were shown, dissolves on the same time scale as one light crossing of the disk. Star charts, in other words, are photographs of weather. The sky they record is real, and it is also already leaving at speeds no eye will ever catch in a lifetime. A snowfall held still by the shortness of our attention. The deeper structures dissolve too, only more slowly. The spiral arms themselves, those luminous sweeps that give the galaxy its portrait, are not fixed rivers of particular stars. In the leading explanation, they are something closer to waves, zones of crowding and starbirth that stars drift into and out of, the way traffic thickens at a slowdown and thins beyond it, the pattern outliving every car inside it. Our own sun, on its 230 million year lap, has passed through arms and left them behind again, many times over. The bright architecture on the map is real, but it is weather, not geography, durable enough to photograph, too restless to navigate by across the spans a crossing requires. So the Great Line of tonight has one final property, and it is almost tender. It cannot truly be drawn twice. The 100,000 light years persist, but the two endpoints, this rim-edge Starfield, that one, are shuffling themselves into new arrangements with every million years that passes. A crossing of the Milky Way would be a journey through a country that repaves its own roads and renames its own towns continuously while the traveler walks. The distance stands still. Nothing else does. Which brings the night at last to the question underneath every other one. The question of the point. Because it must be admitted, no cargo justifies the trip. There is nothing at the far rim of the galaxy that a sane accountant would send a ship for. No mineral is worth 100,000-year freight charge. No colony needs a destination 50,000 light years past 10,000 nearer ones. Every practical purpose interstellar travel could ever serve is served a millionfold closer to home, among the neighboring stars, in the first fraction of the 1% of the line. Judged as logistics, the full crossing is not difficult. It is pointless. But our species has never once measured its longest journeys as logistics, and it did not start with starships. 60 or 70,000 years ago, a span shorter than tonight's single light crossing, small groups of humans began walking out of Africa. No plan spanned the project. No walker saw more than the next valley. Yet the walking did not stop. It continued through deserts and ice, across a land bridge into an empty double continent, southward through unfamiliar forests, generation after generation, until roughly 1,000 years ago, Polynesian navigators steering by stars and swells put ashore on the last uninhabited islands of the Pacific, and the horizon, for the first time in the species' history, ran out. Not one of those travelers could have justified the whole journey. Every one of them, presumably, could justify the next horizon. The crossing of the earth was not a decision. It was an appetite. The accumulated total of 1,000,000 small refusals to stay put. And it is, so far, the only galactic scale behavior our species has ever demonstrated. We are the animal that walked around a planet without a reason that would survive an audit. That is the honest answer to why anyone would cross the Milky Way, and it is neither engineering nor economics. The 100,000 light years is simply the next size of horizon. The mathematics of the 1G ship says the appetite is not physically absurd, that a lifetime in principle can span the whole map. The invoice says every such lifetime pays in farewells. Whether any generation ever chooses to pay is not a physics question, and tonight owes no prediction. It is enough to notice that the species measuring this line is the same one that has never yet, in 70,000 years, left a horizon permanently alone. The ledger is nearly closed. What remains is the walk back through it, and then the answer the title promised. We have walked it tonight. 3 miles an hour, and the crossing swallowed the age of the universe 1,500 times over. We have flown it 500 miles an hour, and the answer still came back in multiples of everything that has ever existed. We have ridden our finest machines against it. The fastest launch, the fastest probe, the farthest traveler. 49 years of perfect flight, and Voyager 1 completes its first single light day this November, with 100,000 light years standing beyond it unmoved. We have granted impossible mercies, Parker's record held forever, and received 150 million years for our generosity. We have consulted the galaxy's own throne star, flung by the central black hole at 4 million miles per hour, and found even the champion needing 17 million years for the line. We have watched light itself, the fastest thing permitted, pay 100,000 years in full, and arrive from an ice age Earth to a telescope on a suburban lawn, carrying the whole span of human history inside the last 5% of its flight. We have mailed what we could. 4 slow letters, plaques, and a golden record, testimony drifting where no traveler can follow. 1 billion playable years of surf and balk and greetings addressed to no one, sent anyway. We have stood at the window of the one-ship physics permits, watched the sky pool its stars into a headlight ahead and close its darkness behind, and seen the universe rearrange its very colors around a crew falling forward at the weight of home. We have boarded the patient arcs and counted their 4,000 generations, and watched meaning die aboard long before the hull. We have met the sleepers, the seeds, and the machines, each surviving the distance by leaving more of the traveler behind. And we have run the one honest loophole to its end. The ship that falls forward at the weight of home crosses the galaxy in 22 lived years and pays for them with 100,000 of everyone else's. The crossing physics permits, and no one has ever been able, or perhaps willing, to build. And we have stood back once at the end to see the whole line for what it is. One tile of a floor that runs 25 tiles to the next galaxy. A neighbor already falling toward us, across a map that dissolves and redraws itself faster than any crossing could finish. That is the ledger, complete. The question on its cover was simple, and it deserves its answer in plain words. How long would it take to cross the Milky Way? The honest answer is that the galaxy quotes every traveler a different fare, and all of the fares are true. On foot, 22 trillion years. a number that is not a duration but a verdict. By jet, 120 billion. By the fastest machines our species has actually flown, between 150 million and nearly 2 billion years, depending on how much impossibility we grant. By thrown star, 17 million. By light, the universe's own speed limit, no exceptions, 100,000 years, paid in full, every crossing, forever. And by the one ship physics permits, but forbids us to build for now. 22 years, lived at ordinary weight by an ordinary crew, at the price of 100,000 years erased between them and everyone they ever knew. The galaxy can be crossed within a lifetime. The lifetime cannot be returned to its century. That is the full answer, both halves, and neither half ever softens the other. If you carry one number out of tonight, let it be the pairing rather than any single figure. 100,000 light years, 100,000 years. The distance and lights fare for it, forever equal. The ruler and the clock fused into a single fact. Every other number of the night was commentary on that pairing. The trillions and the billions measured how far beneath it our machines still fly. The 22 measured how strangely far above it a falling ship could climb. And the pairing itself simply is the width of home, stated in the only currency the universe accepts. So the crossing waits, not impossible, simply unclaimed. It may wait 500 years or 500,000. It may wait forever. The line does not mind. It has been 100,000 light years wide since before there were eyes, and it will hold that width, patient as arithmetic, long after tonight's questions are archaeology. In a strange and gentle way, though, you have not entirely been left out of the crossing. Light finishes it continuously, in both directions, and some of it finishes on you. Stand at a dark window on a clear night, and the pale band across the sky delivers the disk itself into your eyes. Photons that have spent centuries and millennia threading the dust lanes, ending 100,000-year journeys, some of them on the last warm surface they will ever touch. You cannot cross the galaxy, but every clear night, without effort, without cost, without leaving the window, you are where crossings end. That is not a consolation prize. It is the actual shape of our participation, tonight and every night. A species at a window, early in its story, receiving a galaxy it cannot yet answer. 100,000 light years, the longest journey it is possible to draw on a single map, a straight line from one edge of our galaxy to the other. The stars will make it hold still for you, just for tonight. The band across the dark, the quiet arithmetic, the light arriving. Good night.